Example 6.5. Sanderson Meat Processors has asked its lead process engineer to evaluate two different types of conveyors for the beef cutting line. Type A has an initial cost of $70,000 and a life of 3 years. Type B has an initial cost of $95,000 and a life expectancy of 6 years. The annual operating cost for Type A is expected to be $9,000, while the annual operating cost for Type B is expected to be $7,000. If the salvage values are $5,000 and $10,000 for Type A and Type B respectively, tabulate the incremental cash flow using their LCM. Okay, so one thing that we need to point out in this example is that for Type A, the life would be 3 years, and for Type B would be 6 years. And then down here specifically, they're asking us for the LCM. So why is this happening? Chapter 6, it is based on a present worth relation. So yes, we will be calculating the rate of return, but we will be basing our equations on the present worth. If we go back to chapter 4, we're going to see that whenever we have different life alternatives for the present worth method, we must always have equal service. That means that if the lives are different, we have to make them equal. So one of the methods here is the LCM, which is this one. So we're gonna have to go with that. So if we have any different lives in our problems, we cannot tabulate them using the shortcut from example 6.4. Okay, so in this case, we would have to go with the LCM. My recommendation is that you start by drawing the diagrams because it may be a little bit more confusing or harder to visualize than equal lives, like example 6.4. So in this case, let me take the note here saying that these are different lives. Okay, so therefore we will have an LCM, the least common multiple of 6 and 3 will be 6 years. Okay, so let me draw both of the diagrams for Type A and Type B. If Type A has a life of 3 years, then that means that we can fit we can fit 2 cycles into the LCM. So we're going to repeat the 3 years twice. So it's going to require us 2 cycles. Okay, so let's draw this. Okay, so this will be for 6 years. 0, 1, 2, 3, 4, 5, and 6. We have the initial cost, that's going to be in year 0, so that's minus 70,000. Then we are going to have another initial cost. Remember, if we have 2 cycles, okay, then last year of the first cycle becomes year 0 of the second cycle. Okay, so that means that we're going to have another 70,000 over here. Then it says, well, that's the life. The annual operating cost for A is expected to be $9,000. So that means that I'm going to have arrows starting in year 1, going down every year. Okay, that's going to be A equals to minus 9,000. And then they talk about the salvage value for Type A. That's going to be 5,000. This occurs in year 3, and then again in year 3 of the second cycle, which in this case is going to be year 6. Okay, so we have Type A. Now let's do Type B. Type B is already 6 years, and our LCM is 6 years, so that means that we only need one cycle for type B. So we're going to have year 0, 1, 2, 3, 4, 5, and 6. So the initial cost is going to be minus 95,000. We have an annual operating cost of 7,000. And we have a salvage value of 10,000. Okay. It's easier if you have the diagrams first, because now we need to fill out our table. So I have my headers here ready. Okay, so there you go. We want to be able to see the diagrams. So we know that we must order them based on the initial investment, the P. So it says that type, or alternative B will be the one with the highest initial investment. So in this case, it's going to be type B. Oh. That makes alternative A type A. And then we're going to have our incremental cash flow column over here, which is type B minus type A. Okay, so as I mentioned, we cannot do the shortcut version in which we just get year 0 and then we get years 1 through 6. The reason being is that we have these additional cash flows in the middle. So from years 1 through 6, we're not going to have a uniform amount. In this case, we are, but for LCM in general, since you will be repeating the cycles, it's not very feasible to have 1 through 6. Okay, I mean, yeah, 1 through 6 in one row. You would have to write them down separately. Okay, so we would have to do year 0, year 1, year 2, year 3, year 4, year 5, and year 6. Okay, so you would have to put year by year whenever you have the LCM. Okay, so now that we're looking at the diagrams, we know that in year 0 for type A, you have minus 70,000, and in year 0 for type B, you have minus 95,000. Okay, then year 1, what's going on here? We have minus 9,000 here, minus 7,000. Year 2, same, minus 9,000, minus 7,000. And here's where things change a little bit in year 3, because here we have 3 cash flows in the same year. So you can either combine them at once or just list them. I'm going to list them individually here. So we have the minus 70,000. We have the minus 9,000. Don't forget that one, because there's an overlap there. And then there's a positive 5,000. Don't forget to list all 3. Okay. And then on this side, we have the same minus 7,000. Okay, so we keep on filling out the table. We have minus 9,000, minus 7,000, minus 9,000, and minus 7,000. When we get to year 6, you will notice that you also have 2 cash flows here. You have the A, and you also have the salvage value. In the previous example in 6.4, we had the last year repeated. So remember that we had, in that case, it was 1 through 25 with the same A, and then we had the 25 or the 25th year separately. Okay, but in this case, we're going to combine them. So we have the last year, year 6, and we must put the two cash flows here and the two cash flows there, just like what we did in year number 3. Okay, so for type A, we would have minus 9,000 plus 5,000, and for alternative B, we will have minus 7,000 plus 10,000. Okay, so now that we have our table filled, we must get the incremental cash flow. Okay, so remember, we're going to be using this minus sign. So if we have a negative here, it would be minus minus. Okay, so let's start with the first one. Minus 95,000 minus 70,000. Okay, which is going to give us minus 25. Then it's going to be minus 7,000 minus 9,000 positive 2,000. This is the same, so I'm just going to put the 2,000 here. Now here it changes a bit, so it's going to be minus 7,000 minus, I'm just going to write down all this, minus 70,000 minus 9,000 plus 5,000. This will give us positive 67,000. Okay, then these two are the same as the ones on top, 2,000, 2,000, and this one will be minus 7,000. Oops, that the minus, you can see the minus sign, plus 10,000 minus 9,000 plus 5,000. Okay, so this will give us a total of positive 7,000. Okay, so all of these right here are going to be the numbers that we will be using in the next step for the rate of return analysis. Okay, so these are very important in order to solve a problem like this. Now here we're not going to be solving it, we're just practicing how to fill out the tables. But how would this look if you were to translate it into a cash flow diagram? Okay, so let me draw it below. Okay, so this would be also for 6 years. Okay, and this is the incremental cash flow diagram, or the resulting one. So we would have year 0, 1, 2, 3, 4, 5, and 6. Okay, and in year 0 we have minus 25,000. Then years 1 and 2 we have positive 2,000. Then year 3 we have 67,000. Then we continue with 2,000, 2,000, and then 7,000. Okay. One thing that I want to point out here, because again this will be applicable to the upcoming step, is that these 2,000s that you see here in the end are going to be an A. So we will have an A of 2,000. Okay, but what's going on here then? Okay, so that means that, and I'm going to put this in a different color. Okay, so we would have a cash flow that fits in here. So this would be the 2,000 plus 65,000. Okay, so this one right here will be part of your A. Okay, and this would be, we can say that this is an F in year 3. Same thing here, you're gonna see that you may fit an A arrow right there. So this 7,000, you will be breaking it down into two amounts, which is the 2,000 for the A plus 5,000, which in this case will be your salvage value or your F in a year.